All right, we're given the trailer, which is this mass here on the slope. We're given the 5 degrees. Actually, we're just given these things. We're given the limiting tension, maximum allowable tension in this trailer hitch, 5,000 newtons. We're given the mass of the trailer is 2,500 kilograms. Coefficient of friction, 0.1. Slope 5 degrees. And then we have to know 9.8 meters per second squared. That's the acceleration due to gravity. And that's what we use to calculate some forces. So the one thing, the best thing to realize here is since we know the motion of this mass is going to be along the road, parallel to the road, in a path parallel to the road, we are very interested in the forces, or actually the components of the forces that are parallel to the road that are acting on this mass. Okay, so one of those components that's parallel to the road is actually just straight up given as 5,000 newtons is the limit in that hitch, but the other two forces we have to calculate. Okay, the forces that are pulling this thing down the hill. So one of the forces pulling this mass down the hill is the force due to gravity, but the component going down the hill. Okay, how do we calculate that? Well, we draw a little diagram here, and I move over here, and we're given this angle theta, 5 degrees. We know the downward force that's just straight down on that mass, that's just, I have it labeled here Fg, but that is just the, we have to know this formula, that's just the mass of the trailer times acceleration due to gravity, mg. Okay, so that Fg equals mg. I wrote the numbers down here. I didn't calculate it out because we want to do all our calculations at the very end when we did all the algebra to simplify as much as possible. But anyway, that force down the hill due to gravity, I'll calculate it like this. I know this angle and I know this total force, which is the hypotenuse of this triangle. So all I have to do is say, well, sine of 5 degrees equals opposite over hypotenuse. So opposite over hypotenuse, little algebra, F1 equals this Fg times the sine of theta, but I know that Fg is equal to mg. And so that's cool. I've got one of those downward forces that's parallel to the road. The other force that's parallel to the road is the frictional force, F2. Okay, to get F2, I have to calculate, first I have to calculate Fn. Fn is the force normal to the road from gravity and this mass. Okay, so that Fn is, I know this angle again, so I go cosine of theta equals adjacent over hypotenuse, right? Fn over Fg. So I wrote that there, Fn over Fg, algebra, rearrange, and the Fn is equal to that. And then I have to know that given for frictional force, which is what this downward force is, F2, downhill force due to gravity is F2, I have to know that this formula, that downward force along the path of motion due to gravity is just equal to mu times Fn. Mu, this is just a character, and that is the coefficient of friction, mu. Mu equals 0.1. I could have used another letter, x, whatever. I just used mu. So I calculated F sub n from trig, and I know this formula, so I can calculate F2. So this is cool because now I've got all these forces. I've got the force that was given. I've got the downward force down the hill due to gravity, F1, and I've got the frictional force that's going downhill due to the friction by F2. So the final thing to realize is F equals ma. I have to remember this, okay? In this formula, F equals ma, F is the total force acting on the mass, okay, along the axis of acceleration that I'm interested in. So total force, F equals mass times acceleration along the axis. So I just rearranged this. Acceleration is equal to the force over the mass, and then do this. So the total force is the tension provided by that hitch, and then minus F1 minus F2. Why did I say minus F1 minus F2 when I said that it was the sum of all the forces? Shouldn't I add all these up? Well, I really am, but the way I drew this here, F1 is going the opposite direction of this tension. So when I add F1, I'm actually adding the negative of F1. So when you look at your diagrams like this, F1 opposes T, so it's a minus. F2 is going the opposite direction as T, so I put a minus there. And so anyway, I can put some things here, and I can do a little algebra here to simplify it to this. Okay. Do the calculation, and this is what I got right here. So 0.17 meters per second squared is the maximum allowable acceleration before that hitch will break. That's what I got anyway. Thanks for watching. I'll just show that. If you want to pause, and I could show all that. If you want to pause and see something.